Okay, we are now finished proving all the characteristics that we need about the parallelogram. Now we're going to jump down to the next one that was in our table or in our chart that we filled out, and that is a rectangle. Now a rectangle is a special type of parallelogram with one additional characteristic. And by definition it has 4 right angles, but it has an additional characteristic that we completed in our chart, and that is that the diagonals of a rectangle are congruent. So if I flash back to those, and just pardon the moving around here and making you dizzy, but what we did is we figured out that these 4 things could be easily proven, that they have to always be true by looking at congruent triangles, corresponding parts, or applying some of our parallel line properties from Unit 1. So because a rectangle is a parallelogram, then all of those things that we've already proven about them are true. There's only one additional thing that we have to prove about a rectangle, and that is that the diagonals have to be congruent. So that's the only thing that we have to prove on this rectangle is, why do the diagonals always have to be congruent or equal in length? So we're going to start off with the diagonals of a rectangle are congruent. So we're given that ABCD is a rectangle this time. And it's more specific, it's not just a parallelogram, it's a rectangle. But because it's a rectangle, it has all of those characteristics of a parallelogram, such as the fact that the opposite sides have to be parallel. So I didn't draw the arrows in my diagram right away, because I want to talk about these have to be parallel because a rectangle is a parallelogram. The blue lines have to be parallel once again because of the same idea. So every one of those 5 features that we had before. So whenever we draw the diagonals, we're going to create 2 congruent triangles, and so on and so forth. So I'm going to try to present this in a little unique way here. And the fact is that since I know this is a rectangle and a rectangle is a parallelogram, I know that the opposite sides have to be congruent. So I'm going to use AD. It's not very easy to read, so try that again. AD has to be congruent to BC. Opposite sides of, and we can go right back to our parallelogram, are congruent because a rectangle is a parallelogram. So now I have one side. And because it was a rectangle, we know very specifically that this angle, this base angle at A and the base angle at B, both have to be 90 degrees. So I also know that angle A is equal to angle B, which is equal to 90 by definition of a rectangle. A rectangle is a parallelogram with 4 right angles, or at least 1 right angle, and then the rest of them have to be 90 because of consecutive angles have to be equal to 180 supplementary, or opposite angles have to be equal to each other. So we got lots of reasons why we can provide arguments for that. But we got angle B and angle A equal. So now both of those are right angles. So I'm going to clean up our drawing just a little bit. So alpha is, or angle A is 90 and angle B is 90. So now what I got to do is make you identify the side I'm going to get is side AB. I know that AB has to be the same length in both triangles. Now I'm hoping that you're seeing both triangles here. If not, I'm going to identify them. Property of equality. And I'm going to try to get that highlighted. I think I can find some highlighters here. There's a highlighter. I'm going to try to show you that this triangle here on the bottom, so triangle ADB has to be congruent to this triangle here. They both have, I guess I better go back to my pens so I can get back to pens. They both have an angle that's 90 degrees. They both have a side that's equal in measure, and they have the reflexive side. So those 2 triangles have to be congruent by angles, or side angle side. So I'm going to write down the statement that triangle, and we're going to go DAB has to be congruent to triangle. Now D matches C, and then we're going to go CBA, and this is by the side angle side congruency theorem. So the 2 triangles are congruent. So if the triangles are congruent, then their matching parts must be congruent. And the matching parts that we're interested in are the diagonals, which means AC has to be congruent to BD by CPCTC. Corresponding parts of congruent triangles are congruent. So there's an argument or a deductive proof on why the diagonals of a rectangle are always going to be congruent.